So today we're continuing on with reciprocal trigonometric ratios, which are all ratios that can be obtained by doing the division of 1 by any of our trigonometric functions that we've learned so far. So the first one is called cotangent. And cotangent is the reciprocal of the function tangent. Now, if you rearrange this equality of cotangent of theta equals 1 over tan, you also can get the same equality for tangent. Tangent equals 1 over cotangent of theta. So there, we can say they are reciprocal of one another, okay? But just by definition, cotangent is what we call to be the reciprocal function. And then as a formula in terms of x, y, r, cotangent would be the reciprocal of the formula of tangent, which was y over x. Now we have the reciprocal of that, which is x over y. Now with all reciprocal functions, because now you have another function in the denominator of a fraction, we're going to have some NPVs, okay? So the question for NPVs is what kind of input, what kind of theta, what kind of angle I cannot have there because that angle will give me that value of the trigonometric function equal to 0. And we know we cannot divide by 0. And the tangent values are going to be 0 at 0, pi, 2 pi, so all of the multiples of pi. As a formula, we can say multiple of pi k, where k belongs to z because that counts every single multiple of pi. Okay, on the unit circle, it was at these locations. Okay, at the point, those points were 1, 0, -1, and 0. And when we do the tangent formula, we do 0 divided by 1, so we get 0. 0 divided by -1, we get 0, right? So we want to exclude those angles because it will give us tangent equal to 0, okay? That's the NPV for cotangent. It doesn't exist without that NPV mentioning. Okay, so cotangent is usually pretty straightforward. Cosecant is the reciprocal of sine. So cosecant of theta, the short version, it's CSC of the angle equals 1 over sine. The sine formula in terms of yxr was y over r. The cosecant would be vice versa, so r over y. And then sine of theta is, again, at the denominator. We have to figure out at which location, what kind of angles will give us that function equal to 0. And those locations are exactly the same ones like cotangent, right? Because sine here is 0, and then sine here is 0, and just keep on skipping, so it's the same thing, pi k. NPVs. And you have the examples underneath the formula for the NPVs, just to give you a concrete example in the unit circle, but that's usually what we write when we solve trigonometric equations later on. So the last one for reciprocal function is called secant, in short sec. And then it's 1 over cosine. Now, where does cosine or where is cosine going to become 0 at what input? So cosine is going to become 0 at the pi over 2 odd multiples. This is the point 0, 1, 0, -1. That's the value of cosine in the unit circle, the first one, the x, right? So you want to exclude those locations, those angles, and this is how we write odd multiples of 90 degrees or pi over 2. 2 pi k, pi over 2 or 2k plus 1, and k belongs to z. Formula for secant in terms of x, y, r is r over x because cosine was x over r. Similarly, how we said here for tangent is the reciprocal of cotangent and vice versa. We can say the same thing about sine and cosecant and about secant and cos. We can rewrite that and create a new equality, okay? Sounds good? Okay, so that's just the intro of all of the functions. You can definitely go back to it when you need those formulas. Let's have a look at some examples and see how what kind of questions we may be asked for the reciprocals. And they're basically the same thing like we've done for the primary trigonometric functions. You just now have to apply them for the reciprocals. Secant of 420. So what we want is we want to know 420 in which quadrant will lie. So for that one, you might need a little diagram, or you just might know it from the beginning. So one rotation will make it 360. And then how much more to get to 420? 60, right? So right there in quadrant 1, with theta r being 60 degrees. Theta r, or the reference angle, is always this positive angle, acute angle, so smaller than 90, the closest distance from the terminal arm to the x-axis. So theta r is 60 degrees. And we need theta r because we don't want to memorize all of the values around the unit circle. We want to just stick with the first quadrant. And then we're just going to apply the sign when our functions are in various quadrants other than number 1. So secant of 420 is going to be the same thing as secant of 60 degrees. And it's going to be positive because in quadrant 1, based on the CAS rule, or even if you want to base it on the Cartesian plane points, they're all going to be positive in quadrant 1, right? And secant is the reciprocal of cosine, so then you're going to go 1 over cosine of 60. The value of cosine of 60 is half. The reciprocal of 1/2 is 2. So the answer is 2. Any questions for A? We're good? Okay. B, 3 times cosecant of 7 pi over 4. So first we're going to focus on cosecant of 7 pi over 4. And then if there's any other operations around the functions, then we can sort of put them together at the end. If it's simple like this one, definitely you can carry it at the same time. But sometimes it comes with multiple operations or multiple functions in the question, right? So cosecant of 7 pi over 4. I'm focusing on the angle first. I want to give it a location, so which quadrant around the unit circle, and then I want a reference angle so I can go to the values I memorized in the first quadrant of the unit circle, okay? So, which is the quadrant for 7 pi over 4? Quadrant 4, okay? And what's the reference angle? Pi over 4, that's the reference angle, okay? So now we are saying that cosecant of 7 pi over 4 will be the same thing as cosecant of the reference angle. So we put that there. But the values of cosecant are going to be the same sign as the value of its reciprocal, like sine. So based on the CAS rule, sine values, are they positive or negative in quadrant 4? Negative, because only cosine and now its reciprocal, which is secant, will be negative, will be positive in quadrant 4. The other ones will be all negative, okay? So based on the CAS rule, you can just put a negative there. Only then these two are the same thing or equal, okay? If you leave out the negative, then they're not equal, okay? So then we do equals negative 1 over. So we're going to the reciprocal function now. So 1 over sine of pi over 4. Negative 1 over square root of 2 over 2. Negative, the reciprocal of square root of 2 over 2 is 2 over square root of 2. Let's rationalize and see what happens. we get negative 2 square root of 2 over 2. And then the 2's will cancel out. And our final answer is negative root 2. Any questions for B? Yeah, they times by 3, that's right. Thank you for reminding me. Then you times it by 3 or do the other operations around them. Almost forgot about that one. So 3 times negative root 2, it will give us negative 3 root 2, our final answer. And that's a very common mistake, especially if you divide these ones into section, like step 1, step 2, step 3, you might forget the final step to put them together, which is very common, just like I've done it right now. So you want to make yourself like something like this, number 1 and then number 2, just so you remember and you don't leave it out. Okay, good work. Moving on to the next page. We have 3/5 tangent of 3 pi over 4 plus cotangent of 11 pi over 6. So we'll do that one first, we'll do this one second, and then at the end, we're going to put them all together. So tangent of 3 pi over 4 quadrant 2, the angle 3 pi over 4, and theta r is pi over 4. So tangent of 3 pi over 4 is the same thing as tangent of pi over 4, the theta r value, but negative, because in quadrant 2, only sine and its reciprocal will be positive, the other ones will be negative, okay? That's how CAST rule works. So we're right here, only sine is positive and cosecant, the other ones are negative. Okay, so the answer to this one is negative 1. Number 2, cotangent of 11 pi over 6. This angle is in quadrant. Quadrant 4, thank you. And theta r is pi by 6. So equal. The first thing we do is replace the given angle with the reference angle, right? So we say it equals to cotangent of pi over 6. And then we think about the quadrant that will give it the appropriate sign for the appropriate equality now. So we're in quadrant 4. Again, based on the CAST rule for this question. In quadrant 4, only cosine and secant are positive, right? The other ones are negative. So we have a negative here. We haven't memorized the cotangent values. Of course, we have to go through tangent. So in negative 1 over tangent of pi over 6. Negative 1 over tangent of pi over 6 is root 3 over 3, or in the unrationalized form would be 1 over root 3. If that's the one you have, that's fine, whichever, okay? And then we have negative 3 over root 3, and then we're going to rationalize it back. And then it cancels out to negative 3. Step 3, putting it all together. So we have 3/5 times -1 plus -√3. So -3/5 minus √3 amplified by 5, -3 minus 5/3 divided by 5. Any questions for me? Okay, your turn. Let's work on these. 33 until 45. FYI for the your turns, they're not in order, right? Somebody told me last class. So find the page that corresponds with these questions. I haven't changed the questions. I just I've switched the order of the notes around. So you should have the solutions, just not. Okay, peeps, let's go on. I forgot to stop the recording. No. A big, like 15 minutes. Okay. What are we doing next? How to find the coordinates of a point on the unit circle when a point on another circle is given. Example 4, find the coordinates of p theta, assuming the point p theta lies on the intersection of the unit circle and the line segment joining the origin and the point -4, 3. Support your answer with a diagram. Even if I wouldn't be asked to do a diagram, if I don't make sense of a question involving points and circles, I would always do a diagram for myself just to remind myself, okay, this is how I approach this question. So the point -4, 3, you can plot it on a Cartesian plane. So -4, 3, it's about there. And there's a line segment that goes through it and the center. And then here at or around the origin is our unit circle, because that's the unit circle that crosses through the ones of the Cartesian plane. And then that's our P right there, P theta. That's the angle theta right there, or like, let's put it right there. Let's put this angle right there. And that's the triangle that we've seen we formed in both our circle with the center at 0, 0, or the unit circle. It doesn't really matter which one, it's the same angle. Okay, the central angle theta is there or there inside. And that's where P lies. P theta, which is the point on the unit circle, has the coordinates cosine of theta, sine of theta. So to get the coordinates of this point on the unit circle, all I have to do is find the cosine of the central angle of that angle, theta, or cosine or sine, right? It will give me the x and the y coordinate of this point right there. Make sense? Okay. Now, what does cosine of theta equals to? Well, we've done this in last class's notes. Cosine equals x over r. What the sine of theta equals y over r. Now, looking at my diagram and my point, which is the -4, 3, I know the value of x is 4, right? Or -4 if you want to keep the sign, it doesn't really matter. And I know the value of y is 3, right? That's x and that's y. Now, if I want to use these formulas, I also need to know the value of the r, right? Or the hypotenuse of this right angle triangle. So what I'm missing is r. What is r equal to? 5, that's right. It is 5. But let's say we don't know it's 5. We want to find it algebraically. We have to apply it in the equation of the circle, right? So r squared equals x squared plus y squared. R squared equals -4 squared plus 3 squared. R squared equals 16 plus 9 equals 25. So R equals square root of that, 5. Now I have everything I need to answer the question. I have x, I have y, and I have r. What I have to do is plug in. So cosine of theta equals x is 4, r is 5. And either you take the negative from your x, because you know it's -4, right? Or you go back to your CAS rule, because that will help you as well. Obviously, your angle is an angle in quadrant 2, so cosine values will be negative in quadrant 2, right? But the x itself, being a -4, helps you out. So you can avoid the CAS rule if you've forgotten it. Make sense? How about sine of theta? Sine of theta is y, which is 3 over r, which is 5, right? This will also give you a positive value because in quadrant 2, sine values are positive if you think about your CAS rule. Okay, so now what is the point coordinates for p theta? The point that lies at the intersection of that line with the unit circle. The coordinates are -4/5, comma, 3/5 in that order. So cosine first, sine second. What I like to tell my students is, when in doubt, when you're asked to find cosine values, sine values, and the question sounds complex or complicated, okay? Think about x, y, r, because a lot of them just reduce to that. If you know x, y, and r, you can find any trigonometric value you want for an unknown angle. In this question, we didn't really know what the angle was, right? Did we? It wasn't mentioned what kind of angle we were working with, right? But if I know x, y, r, I can figure out those trigonometric values. Because I have these formulas, right? Which is, again, they're coming from the opposite over adjacent, the opposite over hypotenuse. You know, all of those trigonometric ratios in the right angle triangle. We're just replacing them with x and y in the Cartesian plane and r for the hypotenuse. Okay? And by the way, these formulas are in your formula sheet at the back of the formula sheet with the unit circle. So if you forget them, you can always look on your formula sheet. Okay, now what are you going to do if you're asked if a point is or is not on the unit circle? Well, how do you know a point is on a unit circle? But it has to match the formula of the unit circle for any circle that we call unit circle. Which means if I took the x squared and I add the y squared to it, I always will get 1, right? The radius has to equal to 1. So if I take a given point and I test it against this formula, the left-hand side calculation should be giving me the right-hand side equaling to 1. Otherwise, if it doesn't equal to 1, then it's not on the unit circle. If it does equal to 1, then it is on the unit circle. So let's test it. This is the x. Make sure you put it in bracket. This is the y. And the reason why I want you to put it in bracket when you plug it in is because you're going to square it and the negative will disappear, right? The negative value squared becomes a positive. So -5/13, you square it. Plus 12/13, you square it. So that's the left-hand side of that. And now we're going to calculate. I'm not going to assume it equals to 1. I don't know. I'm testing it, right? So -5 squared is +25. 13 squared is 169. 12 squared, 144. 13, 169. When you add fractions, we keep the denominator, so we don't add it. We just say 169 again. And at the top, 25 plus 144, which is 169 over 169, which equals to 1. So our left-hand side in the formula of the unit circle is the same as the right-hand side, which is 1 now, right? So therefore, this point is on a unit circle, right? Point is on the unit circle. I like to always give a question like this in a test. Really easy, 1 mark question. Just plug it into the formula, test it, say yes or no. Okay, how about the second one? Square root of 5/8, everything squared. Add 7/8, everything squared. Let's see. Square root of 5 squared is 5, 8 squared, 64, 7 squared, 49/64. 49 plus 5 is 54 over 64 does not equal to 1. So we say point is not on the unit circle. Doesn't mean it's not on some circle, but it's just not on the unit circle. The circle that has the radius 1. Determine the y-coordinate for the point 1 over 4, comma, y on the unit circle in quadrant 4. So we know that this point is somewhere in quadrant 4. And we know the x is 1 over 4, but we just don't know the y, right? What kind of sign will our y have in quadrant 4? Is it going to be positive or negative? Yeah. In quadrant 4, y is going to be negative. So we're going to keep that in mind when we're going to get the y in this question. Now, because this question tells you the point is on the unit circle, we know that these two coordinates, x and y, if you apply them in the formula for the unit circle, then it's going to have to equal to 1, right? So here we don't test it. We already know it already equals to 1. So we have 1 over 4, we square it, plus y, we square it. We already know it equals to 1 because it belongs on the unit circle. Make sense? So now you just calculate it. 1 over 4 squared is 1 over 16 plus y squared equals 1. And then y squared is the one we need. So y squared on the left, 1 over 16 on the right. So 1 minus 1 over 16. Y squared equals, what's 1 minus 116? Without even doing the expansion. 15 over 16, that's right. And now square root it. Now, when you square root in this equation, regardless of us looking for a value, it's always going to be positive and negative because you are solving an equation here. But we already know the value we are choosing is going to be the negative of this, okay? So y is square root of 15 over 4. And it's both positive or negative, but our y in quadrant 4, the y is going to be negative root 15 over 4. If the question didn't tell us that it's in quadrant 4, then we would have to say, okay, in quadrant 4 is negative, in quadrant 3 also negative, in quadrant 2 positive, right? So kind of go around and put all possibilities, right? Not in quadrant, yeah, but not in quadrant 2 or 3, just in 1 and 4 because x is positive. Okay, so that's these are the questions with points on the unit circle. Either you get to prove that a given point is on a unit circle, either you get to find a missing y. So last set, I think, of questions before we do calculator questions will be how to find exact value when the argument angle is missing. These questions are very similar to the one that we've done just now. This one we've done after the break. It's very similar to this one. So I sort of group them all in the same category. Find your x, y, r, and if you find the x, y, r, then you just plug them into the formula and you find what you asked for, okay? So if you know this, you will know that, and that's very, very similar. Okay, So given cosine equals the value negative √3/2, and theta is between 180 and 360, find the exact value of a sine of theta. So this one can also be done by knowing your unit circle really well, okay? And I've taught that in the past, giving you, oh, if this is on a unit circle, do this way. If it's not on a unit circle, do the other way. It became a bit confusing for students. If you know that, you can definitely use the unit circle. I want to give you one method that fits them all. Okay, that's what I'm doing, okay? But I'm not going to be against you using the unit circle and finding that method I used to teach in the past as well, okay? So given the cosine, so let's write cosine of theta equals negative √3/2. One thing we know about cosine values is their formulas. So I know that I can obtain cosine values by knowing the x coordinate and by knowing the radius, right, in a circle. So x/r is the formula for any cosine value that I'm trying to find. So the equivalent value for x would be √3, and the equivalent value for r would be 2, okay? Now, if I know x, if I know r, can I find out what y is? Yes, all you have to do is apply the formula x² plus y² equals r², which is the same formula we use for the unit circle, but then r is 1 in that. It's a particular case of those kind of circles, okay? So this formula applies to any circle. The one that equals to 1 only applies to the unit circle, okay? Now I can do that and I can find out, but before we go into that calculation, we also want to analyze the sign that we got for the cosine value. Now, in which quadrant cosine values are negatives? So let's put the CAS rule up here. We know that in quadrant 1 and 2, these are the positive locations for the cosine values, right? And that means the other ones in 2 and 3, cosine values are negative. So in 2 or 3. Now, why do I need that? Well, because at the end, you asked of me to find sine of theta. So depending on which quadrant this given value came from, then I'm going to know how to give a sign to the sine of theta. Okay. Now I have a little bit extra information about theta though. I have also information about where it's located. It's somewhere located between 180 and 360. 180 and 360 covers quadrant 3 and quadrant 4, right? Agreed? Now we're going to cross over these two information. The cosine value can only be negative in 2 and 3, and the theta is telling me is either in 3 or 4 in that interval. So if these both stand correct, which quadrant my angle must be in? Quadrant 3, if both of those are standing at the same time, right? Does that make sense? Why not? So negative 2 and 3, either 2 or 3, but then I have information about the angle, either 3 or 4, I don't know which one. So if both of these are given to me at the same time, then which one narrows it down? It must be in quadrant 3, because that's where they overlap. Okay? Sometimes you don't have that piece of extra information, and then you have to like go between the two quadrants, right? But if you have extra information that narrows it down, you want to only work in one quadrant. If you don't want to keep giving, oh, if it's in quadrant 2, I'm going to give it this sign. If it's in quadrant 3, I'm going to give you the other sign, right? You want to have a narrowed down quadrant for the simplicity of your final answer. Okay. Everything is done. I have the quadrant. I have the method. I'm going to find my missing piece, which is y. And then we're going to find it, right? And then we're going to get to the sine of theta, which is the question. So x is √3. Let's square it. Y is not known. I want to find it. And r is 2. Let's square it. So y squared equals 4 minus 3. So move this one on the other side. Y squared equals 1. Square root both sides. Y is positive or negative 1. if you have, again, X, Y, R, you can answer any question. The question for this one was find the exact value of sine of theta. Sine of theta formula is Y over R. I don't know what Y is 1. I don't know what R is 2. All I have to do is decide the quadrant sign. For sine values in quadrant 3, we have negatives or positives. Negative. And that's the final answer.
You have this information before doing this math.
Yeah.
You still want to do the math.
I don't want to do the math. I want to give you one approach that solves any kind of questions. The one that's like this, example 8, or the ones that gives you values from the unit circle. If you know that sometimes when you get the unit circle values, you can get it from the unit circle, you're welcome to approach it like that. But like from my experience teaching this course for almost 8 years, when I give too many methods, people get confused, okay? So I'm giving one method that matches them all. And then you guys, if you're kind of seeing more than, just what I'm giving you, then you can see, oh, there's another way to do this one. For sure, go ahead, okay? Make sense? Okay, let's do one more. Now you're given sine theta value. So if sine of theta is 2 over 7, and theta is pi over 2 to pi, find the exact value of tangent of theta. So when you're given a value, other information, and you're trying to find another value, when you have no idea what the angle is, think of X, Y, R. That's the way you approach all of these questions. X, Y, R, find it, okay? You always start with sine of theta over 2 over 7. You want to know, narrow down the quadrant, and you want to know what you have. Do you have an X? Do you have an Y? Or do you have an R? You have to have always 2 pieces of information from the formula of that given function. The formula for sine is Y over R. So we know Y, we know R. And because we're trying to find tangent, which formula is Y over X, we need X, right? We don't have it. So then we need to find X to get there. Now we need to narrow down the quadrant the angle is in, because once I find X, I'm going to get a positive and a negative value. Which one is going to be? Finding the quadrant of the unknown angle, it's going to help me narrow it down. If I only look at this given from sine of theta equals positive 2 over 7, this positive idea gives me that the theta, this angle, is either in quadrant 1 or 2, because that's the only places I will get values for sine positive, 1 or 2. Here? Okay. But then I know also a bit more about theta. This theta is between pi over 2 and pi. Pi over 2 and pi. That's where pi over 2 is. That's where pi is. What quadrant is that one? 2. So when you cross these, obviously your theta is in quadrant 2. You have no choice, right? So I like to highlight it or circle it so I remember at the end, for whatever value I'm trying to calculate for, in this case for tangent, I have to think, if tangent, what kind of sign will take in quadrant 2? Because I know the sign is positive in quadrant 2. And we need to find out the answer to that with the appropriate sign. Okay, so let's put it into the formula for X and find it. So X squared plus Y squared equals R squared, the formula for any circle with a center 0, 0. X is unknown, Y is 2, square it, R is 7, square it. X squared equals 49 minus 4, because 2 squared goes on the other side. X squared equals 45. Square root both sides. X equals positive, negative. Now, can we simplify that 45 into a mixed radical? when you split 45 into two factors, one of which is a perfect square. You can do, yeah, that's a great question. We can't do plus because if we do plus, we cannot split up the root anymore. So if you do square root of 25 plus 4, in this case, you cannot, it is not equal to square root of 25 plus square root of 4. That rule doesn't exist, okay? And if you test it with your calculator, you will see those two sides are not equal, okay? The only thing that would work is here if you have times, and then the rule would work for times. That's why I asked what two factors, because factors are the participants to multiplication, okay? If I want to ask you about addition, those will be terms. What two terms? Yes. 9 and 5, right? 9 times 5. And then we can evaluate the 9 as 3 in front of the square root of 5. Because this will split up into square root of 9 times square root of 5. Square root of 9 is 3. Square root of 5 stays as a square root. Okay? Now, those are our options for x, either positive or negative, 3 square root of 5. Now we have to find the tangent value. That's the question. What's tangent of theta? We know it's y over x. Y is 2. X is 3 times square root of 5. And now we know we're in quadrant 2. Tangent values in quadrant 2 are negative. Because tangent is positive where? In 1 and 3. In quadrant 2 and 4, tangent will be negative.
Like get rid of the root 5 and 5, no?
That's right. Because since now we have it plugged into the formula y over x, and this would be an okay answer. But usually in math, when you work with roots, square roots, I mean, you never want to have your final answer as a square root in the denominator. So for that reason, we always rationalize the final answer that end up with square roots in the denominator. Okay, so let's rationalize. What kind of multiplication do I need to get rid of that square root of 5 in the denominator? Yeah, root 5. And I have to duplicate it at the top as well because I want to multiply by 1, because multiplying by 1 does not change the original value. And then we get negative 2 root 5 over 3 times 5, which is 15. That's the value of tangent of theta. Three and 15 for 45. It would, to split up the 45, so you're right. So root 45, it does equal to 15 times 3. But then when I do the separation, I'm kind of stuck now because none of these ones evaluate fully, right? So I need that perfect square number, the 9, the 50, the 16, the 25. So all the perfect squares that actually I can extract from the square root. Yeah. But yeah, the formula, the separation of the two separate radicals would work for any kind of factors. Okay, good work. So moving on then to the next break, 7:16. I'll give you until 7:30. So 99% of your questions are all non-calculator question where you have to give exact values, right? But obviously, because we are in in a very advanced era of computerized systems, you can calculate any trigonometric function or ratio using a calculator, right? So your calculator has or any scientific calculator should have sine, cos, and tangent buttons. And then if you want to find the reciprocals, you just have to do 1 over, so divide into 1 the sine, cos, or tangent, okay? Now, we will encounter a slight issue with the units of our angles. So when we do sine of an angle, your calculator needs to understand what kind of unit you're trying to put that angle in, okay? So if I do sine of 30, okay, it should give me 1 over 2 or 0.5. If it doesn't give me that, that means this 30 degrees is not in degrees in this setting, right? So I have to make sure that my calculator is in the right setting if I want this 30 to be degrees, right? Now in this PI calculator, the settings are into, I think, mode. Yes, in mode. And you just switch between radian and degree. So I need a degree, I go there and press enter. Your scientific calculators must have another way, right, to get from degree to radian. And there's one extra one called gradient that we don't use, but those are the 3 different measurements for angles, okay? So we want to know how to switch in our calculators between radian and degrees, okay? That's the only little thing we have to know for doing example 9. Determine the approximate value for each trig function. Give your answer the nearest 10, so 1 decimal. Cosine of 47 degrees. You want to make sure your calculator is in degrees. I've just changed mine in degrees. So then I do cos, find your cos button, then enter 47, 0.681. So approximately the nearest 10th, 0.7. I just sent them to you. Okay. Sine of 225, sine, 225 again degrees, negative 0.707. So approximately negative 0.7. Okay. Okay, moving on. Cosecant of 5. Okay, pay attention. There's no degrees sign attached to 5. Same to this input there. There's no degrees, right? So that means the input is in radians. You want to make sure your calculator is set up as radians. Otherwise, it will understand you put the 5 degrees, which is not the same thing as 5 radians, okay? So switch between now, back to my setting. I want to switch it to radian. Now I can plug in cosecant of 5 by doing 1 divided by sine of 5, because I don't have a button for cosecant. So 1 divided by cosecant is sine, so sine of 5, negative 1.04. So approximately negative 1.0. We're staying with radians, negative 11 pi divided by 19. Tangent, I do have a button for the negative. Make sure you choose the right negative, not the subtraction, that you're gonna get an error, right? So the negative values right there for me. And 11, choose your pi button, not 3.14. divided by 19, close the bracket in this case. 3.94, 3.9.